This is day 11 of Unit 7. We started with this warm-up today, so pause the video, try the warm-up, and then play to check your answers. So the first part, the first question, 20, oops, we want to use 20 times the multiplier. Times the multiplier. Well, the multiplier would be 100 plus 2%, which is 102%, so 1.02 is the multiplier, and then raised to the second power if I'm looking for 2 years. So when we do that, we get approximately $20.81. The second part of the question, or second question, says approximately how long will it take until it's worth $50? So I set 50 equal to the equation, and now it's an x as the exponent, divide by 20, so 5 halves, or 2.5, is equal to 1.02 raised to the x. Remember, we haven't learned how to use logarithms yet, so we're going to solve using guess and check, and doing that, we get that x is approximately 46.3 years. Okay, so today's lesson, go ahead and copy these into your notebook. We started with these. So the first thing, it says that we're supposed to determine growth or decay. Well, this is over 1, so we know that's growth. The multiplier is over 1. A sketch. For a sketch, that's different than a graph, so it's going to be less precise than the graphs we did last week. But I do know, looking at the equation, that the horizontal asymptote is at y equals 0, and I really just need 1 point. So I'm just going to use the y-intercept, substituting 0 in, I get 34. So I'm just going to put it way up here. And I know that it's growing, so I'm going to make the curve close to the asymptote and then growing, and that's a good enough sketch. Again, if it's a graph, then I would be more precise. I'd need the 3 points and the asymptote. Find the percent increase. Well, 1.08 for the multiplier means 108%. That's not the answer, though, because I need to know how much more than 100% it is. So I have to subtract the 100, which gives me 8% growth or increase. Okay, so now we're going to do the same thing with this one. So the 3/4 is less than 1, so that tells me decay. A sketch. Again, I can see the horizontal asymptote is 0 because there's nothing there on the end, so y equals 0. And y-intercept 0, 2. And I know that this is decay going down. So through that point and getting close to the horizontal asymptote, the sketch is going to look something like that. So then I have to figure out percent decrease. So 3/4 I know is 75%, but that's not my answer. That's how much is left after we've decreased. So we need to find how much it decreases by. So we need to subtract that percentage from 100, and we get that the decrease is 25%. Be careful with that. Common mistake students make is just change the 3/4 into a percent and say the answer is 75% decrease. You have to subtract that percentage that you get from the multiplier from 100 to get the percent decrease. Okay, so important information from this question. $40,000 is what I want. I want it in 8 years, and I have 1,000 now. So let's see if we can figure out what the interest rate would need to be. So I'm going to fill in what I know into y equals a times b to the x, like we talked about yesterday. So I know 40,000 is the y. I know the a is the initial amount, 1,000. And I know that I don't know the multiplier, so that is a variable. And the exponent is the time, and that's 8 years. So I substitute in what I know. Now I'm going to solve for x. I'm going to divide by 1,000. So 40,000 divided by 1,000 is 40 equals x to the 8th. I'm going to solve that by taking the 8th root. Now, technically speaking, if we weren't talking about a word problem here, I'm taking an even root of something to an even power. So that's technically the absolute value of x is equal to whatever the fourth root or the eighth root of 40 is. So I would technically get plus or minus the eighth root of 40. However, with this problem, we're solving for a multiplier, and multipliers can't be negative. So I'm just going to disregard the negative, but keep in mind, if this had not been a word problem where we were solving for a multiplier, and I was just solving x to the eighth equals 40, I would need the absolute value in the plus minus. So I'm going to type the eighth root of 40 in my calculator to get the decimal. So when I do that, I'm getting, let's see here, 1.5858, and I'm writing out all these decimal places for right now because I'm not ready to round yet. So that's approximately x. Now I'm going to change that to a percent, so 158.5833175%. That's still not my answer because that's how much more than 100% it is. Or yeah, so I have to subtract 100 to figure out how much more. So 58.58, so forth, %. Now I'm at the end of my problem, and now I'm ready to round. This asks for 2 decimal places, so I look at 3 decimal places, and I say 58.58% approximately. So it's not looking like I'm going to get that $40,000 within 8 years because I don't know of a bank that would give me 58.58% interest. That's a really high interest rate. Okay. Next, we're talking about the lynx population. So we have these lynx that there was 150 in 2003 and there were only 13 in 2014. So we're going to find the rate of decay and we're going to round that to 2 decimal places. So this is similar to the last one. We're going to start with the initial amount, which is 150. We're going to multiply that by x we don't know, and we're going to raise that to the time, which would be 11 years, yep, is equal to the amount after 11 years, which is 13. I'm going to solve that by dividing by 150. I have x to the 11th equals, now 13 divided by 150 is a repeating decimal. You do not want to cut that off. You want to leave it exact. If it had been a terminating decimal, I would write the decimal here, but 13 over 150 does not terminate. So I'm going to leave it as 13 over 150. Now I'm going to take the 11th root of that, and that is my answer for the multiplier. So x is approximately, and again, I'm going to write out a bunch of decimal places here. So I have 0.80064700344. I'm going to change that to a percent. So 80.06470344%. Now that's what's left after decreasing, so we have to subtract that from 100. To figure out how much it decreased by. And when I do that, I'm getting 19.93529. I probably have enough decimal places now. So now I'm ready to round, and I look at the third decimal place, and that is a 5 or above, so I'm going to round that 3 up to a 4, so 19.94% approximately is the rate of decay. Okay. Next, it asks for us to predict the population for 2017. So this question must have been before that. So I'm going to use that information from above. So I'm going to take the initial amount, 150, times the multiplier. Now, the multiplier we just solved for, right? Right here, the 0.80064700344. Now, you can't use that decimal though, because remember, that's an approximation. Even though I wrote out several places, that's still an approximation. We want the exact. So the multiplier is the 11th root of 13 over 150. You have to use the exact. You can't use the approximation. So the exponent is the time since 2003, since I used 150. It's the time since 2003 to 2017, which is 14 years. So 150 times the 11th root of 13 over 150 to the 14th power, that's what you want to type in, and when you do that, let's see, what do we get? We get 6.6721. Now these are living, breathing beings, so we want to round that up. So that would be approximately 7 links. Okay. Next, let's take a look at half-life. So some of you have chemistry and you probably already know what a half-life is. Some of you have not. Half-life means the time that it takes for half the atoms of the substance to become disintegrated. And we're talking about a radioactive substance here. So that's what half-life is. So we're going to take a look at carbon-14 and we're going to figure out some information about that. So it says that we have this half-life, so you want to include that in your notes. That's the half-life length. And it says archaeologist is using carbon-14 to determine the age of artifacts in carbon dating, okay, which is something that actually happens. They use carbon to help date different items that they found, different artifacts. So we're going to write an exponential decay function for a 24 milligram sample. So that's important as well. So we're going to start with the initial amount, 24. And when we're doing half-life, which is what this is about, half-life always uses the multiplier 1/2. So it's 24 times 1/2, and we're going to raise that to the, in general, it's time over the half-life. Half-life length. And those have to be in the same units. So if they're not, you're going to have to do some converting to get them in the same units. In this particular problem, the half-life is 5,730 years, and the time we're looking for is 30,000 years, so they are both in the same amount of time. So I'm going to take 24, and that would be equal to y. So I'm going to take 24 times 1/2, and I'm going to raise that to the time, which is 30,000. And I'm going to divide that by the half-life length, which is 5,730 years. Again, the years have to be, it has to be the same units for both. So years and years, so we're good. If not, I would have converted. Typing that in the calculator, 24 times 1/2 to the 30,000 divided by 5,734, we get, let's see here, 0. Actually, I don't have the decimal before the, it was 0.63 something, and the number was bigger than 5. So we're going to round that to approximately 0.64, and these are milligrams. Okay. And that is where we're going to stop for today, because I think for most classes, that's as far as I got. I didn't get to the second half-life example for most classes. So we'll stop there. We'll pick up with this lesson tomorrow. So assignment for tonight, you're going to do the problem we skipped on page 20 from last night. You're going to do all of page 22, and you're going to do just these specific problems on worksheet 7 and just these specific problems on worksheet 8. So do those for tomorrow.